Hello, Michael here from Wickerson Studios. I was working on the algorithms for dummies as it meets the Euclid elements. However, with NumPy array, I haven't found a way to bring it into this script yet. I've just basically been taking a look at proposition 45, which says to construct a parallelogram equal to a given rectilinear figure in a given rectangular angle. Rectilinear, oh my goodness. Rectilinear angle. I don't know if I could spell any more incorrectly. Start with ABCD figure, ABCD figure. You can see that I can push that for one parameter all the way over to a triangle, solid blue, from a green triangle to a blue triangle, but anywhere in between, you've pretty much made a mesh, a quad mesh that you can look at. Now, what's nice is you see this B, L, G, F broken into uh, uh, F, H, M, K, and G, H, M, L, and they are pairing beautifully with the area of, say, the green triangle matches the yellow area of the parallelogram, and the blue triangle matches the area of the pink parallelogram. So that's pretty nice. Written a pretty simple script. It's a little repetitive, a little jumbly in here. I really spell things out. I write every detail. I hard-coded in a few things here, which are pretty interesting, because if you go in here and you start playing with the other points of the parallelogram, it doesn't work for every parallelogram. So if we put this one in here, you can see as I move that one, which looks like it might be right about there at 0.5, it works. But outside of that, you can see I'm not producing a larger parallelogram, the yellow and pink sections that match the green and the blue, and that goes the same for anything else. So there's a little bit of hard coding in there, but you can get to your ideal form that works and still manage to keep it parametric. So I will try and grab this, and I really like moving from this diagram all the way through to this one. And for those that want to get into algorithms, but you need the visual assistance of Grasshopper, this is a great means to do it. There's nothing in here I'm using besides points, planes, circles, lines, evaluating those lines, finding vectors, and doing some polylines. There's really nothing complex in here. There's one little mirroring that I do here with a little bit of fancy work on a plane to the z-axis to just mirror this form from here to here, because I actually want to draw each triangle towards the diagonal of B to D. Pretty simple. Grab the script. It's up online through GitHub, and I've done some nice notation here. I was really hoping to bring this into Grasshopper 2, but the text tags really aren't there yet. There's text on curves, but there's nothing, and there's three-dimensional, and they're kind of over the top. I just want something simple in here. So anyway, I really didn't need the hard code every single thing into the size. I probably could clean up the script quite a bit, and I'm sure if I went back into here, there's not too many data analysis you have to use. Fairly nice script. I like it. I've got a huge one in there now. Oh my goodness, what did I just do? Let me go back, get that back to where it was. I just typed in 1. I see what I did. I typed in 1 into the text as opposed to what I was trying to do was just take this and put it into the size so I could start eliminating a little bit of these. I could clean the script up. I'm not going to bother. It is the GhPython algorithms for dummies, EE, my second exercise, C, going back into Grasshopper 1, taking a look at Euclid's elements. Now what I want to do is jazz this up into 3 dimensions in this pattern and start to lift and use numbered arrays or trees to make this much more interesting. And what I've done is I've gone in and I have an algorithm here that can analyze coded or actually pretty complex data systems. You see this one's taking a little longer to run. But you can also call information with this Boolean output C, which allows me to pick and choose pieces. So I've got a better idea of what I want to do in here. I'll keep things simple to start and let the computer do its magic a little later on. But that's it. It's coming from a huge exercise of translating chapter 4 through 7 of the algorithms for dummies. but really trying to apply it to Grasshopper to build some interesting geometries and producing some really nice algorithmic models of Euclid's elements along the way. Very happy to say that this is, this is beauty at its best for me. Somewhere between spirituality, mathematics, and art is where I like to sit. Thanks very much for watching. Michael at Wickerson Studios.